Hi there, this is Penelope and this is the second of the videos on vectors for science for the Level 4 Foundation program. What we're going to look at first is subtraction, and we've already looked at addition in the first video, but now we're going to look at subtraction. Just to refresh first on the addition though of two vectors, and this perhaps goes into a little bit more detail than we did before, except that it's still the same thing. We're still looking to find the resultant vector of F1 and F2 in this case. So we've got F1 as being 2 newtons vertically down and F2 is 3 newtons horizontally above. So what we can do is we can take F1, which is here, and kind of move it so that it's here, so that it starts at the tail of the other one, and then look at the resultant vector. So now we have the triangle that we looked at before. So this is what we need to look at here, and to define it or describe it, we need to find the angle and its length, its modulus, its magnitude. Now, in this triangle, we have a line that's 3 newtons and a line that's 2 newtons at right angles to it. And using some basic trigonometry, we can say that the tangent of angle theta is 2 from this one over 3 from that length there. So tan theta equals 2/3, and then with a little more basic trigonometry, we can find that theta is 33.7 degrees. Now we need to find the length of r. So the length of r, it's the magnitude of r, and we can just use Pythagoras to do this, and the length will be the square root of 3 squared plus 2 squared, which is the square root of 9 plus 4, which is the square root of 13. And we'll need to have that length will be in newtons, or that vector, the length of that vector. In the previous example, we saw that two forces acting on a body can be replaced by a single force, and that was the one that we called R. And that single force has the same effect. Sometimes it's useful to take a single force and rewrite it as two forces that are acting at right angles to each other. So then we can say that F has been resolved into two perpendicular components. Perpendicular just means at right angles. So, as an example here, if the force is 5 newtons in a direction there, 30 degrees to the horizontal, then what we can do is we can break it up into two forces at right angles, two components, one along the horizontal and one along the vertical. Now again, with a little bit more trigonometry, we can see that the magnitude along the horizontal is going to be 5 cos theta, and the magnitude along the vertical is going to be 5 sine theta. Well, in actual fact, it's 5 cos 30 and 5 sine 30, and between them, those forces, those two components, have the same effect as the original force, 5 newtons in the direction of 30 degrees. For another example here, to resolve this into two perpendicular components, we'd say that the horizontal component is going to be 15 cos 40 newtons, and that the vertical component would be 15 times sine 40 degrees in Newton. And that gives you an idea. We've got two forces operating at right angles, and the combined answer is 15 newtons at 40 degrees. Now, we can subtract vectors in the same way as we added them. You remember that subtraction is just the opposite of addition anyway. So here, the same way, subtraction is performed by adding a negative vector. So instead of doing A plus B by putting the end of A to there, if we're going to do subtraction, what we do is we put the opposite vector. Remember I talked about that in the previous video. We're going to put the opposite vector at the end of A. So this one goes that way, and this one goes that way, and then it's still addition. It's adding a negative. It's adding the opposite, and then we join it up with the resultant vector like that. So here, how do we figure out Q minus P? First of all, we've got to find negative P. And negative P, or the opposite of P, is the same length as P, but it's in the opposite direction. So let's have a look at it in the diagrams. What we're going to do is we're going to have to join the opposite of P, so one goes in the opposite direction, to the end of Q, and then here is our resultant vector. So we've got Q minus P. We put the opposite of this one onto the end here, so it's in the opposite direction, and then the resultant vector is Q minus P. Now, if K, in this situation here, if K is just a positive number, we talk about it as being a positive scalar, then Ka is just a vector in the same direction as A, but K times as long. If K is a negative number, then it's going to be in the opposite direction and K times as long. So you can see here we've got A from there to there. Ka is going to be K times longer, but if K is negative, then it's going to be in the opposite direction. It doesn't have to be bigger. It could also be smaller. So it could be that K is less than 1. For example, here we've got K equals a third. So K times A is a third as long as A.